Hey there, I'm Gilad Barash, and welcome to Who's Your Data, the podcast that deals with how data influences life and how life influences data, the human side of data analytics. Today, we chat with Dr. Ira Cohen, founder and chief data scientist at Anodot, about how his company uses a machine learning technique called anomaly detection to help businesses avoid being impacted by surprises. We discussed what anomaly detection actually is. Spoiler, you learn what's normal and then detect abnormalities. Why it's challenging to define your quote-unquote normal, or as the singer Miguel put it, what's normal anyway, and how you can actually report too many anomalies and why that's bad. And also how black swan events such as, a global pandemic that suddenly shuts down the entire world, would affect these techniques. We also discuss what Ira looks for in a potential data scientist, hint, it's not necessarily anomaly detection skills, and what he's excited for in 2021. Let's get to the interview. Hello, Ira Cohen. How are you?
Very good, Gilad. How are you doing?
I'm doing great. I am really enjoying my time in Tel Aviv. And I'm really excited to talk to you about a topic that we've been talking about for some time. And we finally get to sit down and really discuss it. And that is using data and data science and machine learning to prevent surprises in business.
Yeah, and doing this in person is also pretty exciting.
That's the most exciting part about this, finally, after all these months of podcasting. So speaking of, whatever's been happening these last few months, what do you feel is something that has surprised you about yourself during the time of COVID, now that we're kind of starting to come out?
Before COVID, I was traveling all the time, in the office every day, very, very long hours. What surprised me is that how quickly we can adapt to the new situation and make a benefit out of it. So, this last year I've been learning so many new things, opening up the horizon, thinking about, studying new things that I haven't studied, like neuroscience, studying Japanese, doing all sorts of things that I thought I had no time to do. And it's not that I got a lot more time during COVID. I still worked a lot, but all of a sudden, the fact that we were forced to stay home, stay put, not move around, not chase after, the next flight and the next meeting and the next conference, all of a sudden created this calmness that helped me, at least, start doing all sorts of things that I never thought I had time to do.
We were shut in at home, but it kind of opened our minds and our horizons to other things in the world that we can learn, that we can look at, other cultures, languages. So you have been involved in machine learning for how many years now?
Officially, I would say I started machine learning when I started my PhD in 1998. So my background actually is in electrical and computer engineering, specifically signal processing. In signal processing, everything is mathematics, but there's a whole area of image processing in signal processing that I worked with. As a student, I did a summer job at a company that basically looked at images of wafers, of chips, and to find defects in them. And that's when I first saw the tools of machine learning, even though they were called pattern recognition and mathematical tools, being used for the first time. And it really drew me in. And when I was looking for a place to do a PhD, I knew it's going to involve data, it's going to involve image processing. I didn't know it was called machine learning yet. I just kind of learned a few bits and pieces. But it really drew me in because it's really fascinating how you can take mathematical objects, algorithms, basically math, and take data and transform it into something interesting like finding defects in a chip.
Can you talk a little bit specifically about what it is that you identified as a need in the market that brought you to found your company, Anodot?
Sure. So basically, I think the best way to describe it is to talk about how we started Anodot, or how the idea came about. So my partner, David Ray, who's our CEO, he contacted me. I never met him. He sent me a message on LinkedIn. I was working at the time at Hewlett-Packard Software, and he sent me a message. He wanted to chat, and we met for dinner. And he basically described his problem. He was a CTO of a company that had Uber-like competitor, and as a CTO, he had this issue. He had a problem. He implemented a system that collected all the data about what's happening with their application, how many people are asking for rides, how many drivers are on the road, how much money they're getting, how many calls they're getting, how long does it take to load the app or ask for a taxi, how many crashes the app had. Everything was collected so it can be monitored in real time. But the monitoring was done looking at graphs and dashboards or creating all sorts of rules that would alert to somebody in the company that something is happening. What he told me his problem is that because of this fairly manual process, they oftentimes miss really important things that end up costing them money, direct money, by people not taking rides, or causing their customers, the people that want to take rides, to be really pissed off because something's not functioning correctly, and it could be for a variety of reasons. And it drove him nuts because the data was there in real time. It would often take them sometimes weeks to discover it by themselves, or they would hear about it from a customer complaining. Even though the data was there.
They could have known about it.
They could have known about it, but because they can't hire millions of people to look at everything, they didn't know about it until it already lasted for a while. And he asked me, is there a way to do this better? And he heard I have expertise in machine learning, specifically in a field called time series analysis, meaning things that you measure over time. It's like sensor data. And I told him, yeah, the techniques for doing it are known. It's not something we need to think about inventing a new type of machine learning. Just implementing it correctly for a product that can do this for a lot of businesses. And he was a serial entrepreneur. We created a deck, went to a few investors, got our first seed funding, and 6 months later we went off.
The rest was history.
Yeah.
Business runs, and there are business outcomes, but it's hard to identify and anticipate when surprises might happen, when changes, unexpected and fast changes might happen from the normal behavior, and being able to identify those ahead of time as they start or as soon as possible is something that's very, very important.
And valuable. I mean, it has value. So, for example, coming back to that ride-sharing app, one of the cases he described to me is new users that just downloaded the app in a city somewhere in the world. Some of them were not able to complete the registration. Why? Because they depended on getting a text message with a code. Everybody knows that. You get a code, you put it in the app, you complete the registration, then you can use it. And some users in that city were getting stuck in that process because something broke in the app's connection to get the text message because of one provider, one cellular provider in that city, that the connection was broken. So it took them 2 weeks to realize this was happening after they started seeing their revenues go down because they were getting slower new registrations and less rides eventually. So eventually they detected it was happening. But the surprise was started happening 2 weeks before, when something technical broke in that connection for sending the code, and nobody saw it. So it ends up costing money.
A lot of money.
A lot of money.
And so there was this anomaly in the regular normal business process that if only there was a way to detect it automatically and quickly, that would save the company a lot of money.
A lot of money.
And it is indeed this field of anomaly detection in machine learning that is what Anodot is so good at.
Yep.
And so can you talk a little bit more about what that actually means when you say anomaly detection?
Yeah, so anomaly detection in general is a big field. There's a lot of different types of anomalies. The types of anomalies we're looking for are changes of behaviors over time. So when you look at some measurement, let's say the temperature or whatever you're measuring, the number of new users in a city, you're measuring it over time. Typically, that has some pattern to it. Anomaly detection has 2 steps. First, learn the pattern, find out the normal pattern, and then whenever there is a deviation from that normal pattern, you say it's an anomaly. And it's an anomaly. It doesn't mean it's a bad anomaly. It could be a good anomaly. It could be a bad anomaly.
It could be like a spike in revenue.
Yeah, it could be a spike in revenue. And by the way, sometimes a spike in revenue could be a bad anomaly. Maybe it's fraud.
Oh,
maybe it's actually people purchasing. You think you're getting a lot of new revenues. 2 weeks down the road, you'll see that it's not. So that's why you can't say whether an anomaly is good or bad always, but you want to be aware of it so you can react to it as quickly as possible, because if you ignore it, it could end up escalating and becoming worse and worse over time, and it accumulates. So not all anomalies are bad. Now, there are a lot of other types of anomalies, not in things that you measure over time, but that's not the kind of anomalies we deal with. The field of anomaly detection in machine learning is very big.
And so when you are applying machine learning techniques to anomaly detection, it seems to be, when thinking about it, right, you're basing, in general, with machine learning, you're looking at historical data, you're finding patterns in that data, learning them, and then building algorithms that will be able to do prediction or classification or anomaly detection based on that historical data. But by definition, anomalies have less data, have less historical data that you can learn from. So is that a challenge that you need to overcome? Or how does the process work, given that these anomalies, by definition, like I said, you don't see them often, which is why they're anomalous.
Yeah, so by definition, anomalies are rare.
Yes.
If they weren't rare, they would not be called anomalies anymore.
That's my point, exactly.
So and the techniques that we use, and usually are used, there are some exceptions to this, is to actually say, let's not learn the anomalies, what anomalies are, but let's learn what normal is. It turns out that's easier because most of the data is normal. By definition, most of the data has to be normal. So you have a lot of data to learn what's normal. And if you have a lot of data to learn what's normal, all you have to do next, once you do that, is to decide on a test. A test that tells you, when I see some new data, how do I know that whatever I learned normal is doesn't fit it well? Let's take a silly example. If I'm learning to find anomalies in images, and I define the colors of the images as the color palette of an image as what I define normal. And I get a lot of images that are all sky. So my normal will be lots of blue in an image. And now if I get an image of a fire, it will look anomalous because it has a lot of red and not blue. So I need a test. My test will be some statistical test typically that will say, how do I know that this new observation is not explained, but what I believe to be normal. And so I use a lot of examples, and I assume all of it is normal, or most of it is normal, and then devise a test to say, so it will help me say, this is abnormal. Because it's not explained by anything that I've seen, by whatever I learned normal to be.
Okay, interesting.
Very, very, the problem with all of this, what I just described, it's ill-defined, right?
Right, because I have 3 questions already that I want to ask about this. First of all, so normal doesn't necessarily mean stable. It could be that your normal baseline is very erratic, like the revenue from the ride sharing just goes up and down and all around, and it's all over the place on a normal basis, which certainly probably implies some not optimal business practices and on the business side. But is there a possibility where you just can't get a good baseline that is stable enough for you to be able to identify an anomaly?
You will always be able to find some anomalies. The question is, will there be anomalies that you'll miss? And will there be, so I wouldn't even call them anomalies, will there be bad situations or problems that you'll miss because the data is erratic, as you mentioned? You will always be able to come up, no matter what the data is, if you are applying good algorithms for defining what's normal, for finding these patterns. I think the trick is to have the algorithms that can look at all sorts of normal patterns and detect all sorts of normal patterns, not assume that there is one normal pattern.
Right.
And if you have those, you'll detect anomalies. But you'll always be able to detect some anomalies. It's just that you might miss real problems that will hide within the normal. And that for those, that can happen, definitely can happen. And it all depends on how you define the assumptions that you make about how to look for normal. So in the image example that I gave you, I looked for colors only. Maybe I should look for some information of edges, some information of, is there a face or no face in the image? It depends on my assumptions. So
you may want to look at other features other than just colors that might be able to show you
to define normal.
To define normal in a more sophisticated way.
Yes.
Which that leads me to my next question about the normal. In machine learning, in general, there is the concept of overfitting a model, right? Which means that you learn the patterns so specifically in the historical data that you then are only able to identify that pattern, and you aren't able to generalize beyond it to learn sort of new situations. Is there a danger of overfitting to the baseline?
Yeah, absolutely. I mean, it's just like any other things in machine learning. If you choose a model to describe normal that has too many parameters, that basically tries to capture things exactly as they are, then you get overfitting. One simple example is a model that will look only at very short history. It might it will forget the entire past, look only at the last day's pattern, then it will overfit to that day. And there's also the notion of too complex of models, just like in any other parts of machine learning. Overfitting is a problem, and it's even harder to test it, to find it. In classification problems, in supervised problems, it's easier to find overfitting. In unsupervised problem, and anomaly detection is an unsupervised learning problem because you're not given examples of anomalies for two reasons. One, they're too rare. Second, they tend to be very different from each other.
They're surprises.
They're surprises that are oftentimes different from other surprises. It's just like the Tolstoy book. All normal families look alike. All broken up families are different.
Right.
Anomalies tend to, a lot of them, be different. You can't put them in buckets and say, oh, this is this type of anomaly, this is that type of anomaly. I've tried. It just didn't work well. So it's easier just to learn the normal and then let the anomalies be what they are. Interesting.
Well, okay. So you learn the normal and you let the anomalies be what they are. And you touched on the idea in machine learning. Machine learning can be divided into sort of two big realms, supervised learning and unsupervised learning, where in supervised learning, you know the outcome, you know what it's going to end up being. You're trying to either recognize it or predict it, but you know what outcome you're looking for. And this is true for, problems of prediction or classification, where is it spam email or is it not? You can do that because you know what a spam email looks like. You've got enough historical data and you have enough historical examples of emails that aren't spam, so you can classify any new email that comes in as spam or not spam. In unsupervised learning, as you said, you don't know what the outcomes are. You know that anomalies might happen. You don't know what they are ahead of time. You don't know what to look for. So you kind of invert the problem and you say, let me recognize and identify the normal, and I will report on anything that is not normal.
Exactly.
Another, element that we have when we talk about machine learning and about classification and prediction is the idea of false positives and false negatives, meaning false positives are examples where we think, for example, that it is a spam email, but it really isn't, and we misclassified it. And false negatives are the opposite, meaning that we didn't catch that it was a spam email. We thought it was a regular email, but it actually was spam. And these are errors that the models, the machine learning algorithms make, that we have to quantify and measure, and we use those to validate the models and to estimate how well they're working. For example, in digital advertising, a false positive might be showing an ad to somebody that we thought would be interested in sneakers, but they really aren't. And a false negative would be that we missed somebody who really would have been interested and we never showed them an ad. Whereas if, let's say, you're looking at a machine learning algorithm that identifies cancerous lesions on the brain, a false negative means that you missed a lesion and that person's life could be in danger. So the stakes are higher in certain areas of machine learning than others. All that is to ask the element of false positives, false negatives, being able to identify the wrong or misidentify anomalies in either direction. Can you talk a little bit about that and how you address that issue?
Yeah, and that's probably where a lot of our time goes into in terms of beyond developing the product and the algorithms themselves, actually making sure that we minimize both of these. Now, the false positive, what is the cost of a false positive? So I tell somebody there is something going on that you should be looking at. It should interest you. Number of new users, registration is going down in this city, abnormally down. And it's not really happening, or it's not really interesting. This is a false positive. The cost of it is that I wasted somebody's time in that business. The false negative is that I didn't alert that something is happening that could cost money. So on the balance of things, false negatives are much costlier than false positives. But, and there is a big but here, people get annoyed with false positives to the point that they stop paying attention in the future. So the cost of too many false positives, that they start ignoring everything. And then they'll miss the true positives as well. They'll just ignore this. They'll just shut down the system. Think about if you had an alarm system in your house that once every few days alarmed and it wasn't anything. At some point you're going to shut it down and not use it anymore.
That's right.
Even though it can 100% catch all the burglaries. So so it's more of a psychological problem with the false positives.
So it's like crying wolf.
It's crying wolf, and it has a big effect. So we focus a lot on reducing the false positives because we know that we catch almost everything. There are very few false negatives that we have, but the false positives cause people to ignore the whole thing altogether. So once you identify that, you start focusing on reducing the false positives. And what's interesting for us is that a lot of the false positives are not the problem of the algorithm detecting that there is an anomaly and somebody says, no, this is not an anomaly, the algorithm is wrong. A lot of times what we hear is, yeah, you caught a real anomaly, but it doesn't have any business impact for me to care about it.
Right, I just don't care.
I just don't care. And that's the false positives that's hardest to eliminate because they say, yeah, this is a true anomaly. Revenue dropped by 20%, but it went down from $100 to $80. And you know what? In the grand scheme of things, it's not worth for me to even, stop my job and handle it. I'd rather wait to see whether it goes away by itself. And a lot of things go away by themselves. That's the hardest part in creating a robust product because, again, if you alert on all those small things, when it comes a big thing, they're not going to notice. I mean, we've had cases where the same anomaly sent to two different people in the same company, one would say, oh my God, this is so important, and the other would say, why did you send this to me? We do get feedbacks. We put into the product a mechanism that users can actually provide direct feedback on the anomalies that they handle to know whether it's good and bad. And then we do fitting based on kind of the user, or at least the part of the company that the user comes from.
Interesting. Okay, that's a great idea.
And that's a way to trade off this problem of false positives with not alerting somebody that there is an anomaly.
So it's
that should be
anomaly
interesting.
personalization.
Something like
to
that. Because it's
the
so
department.
subjective. I mean,
Yeah.
it's not so subjective, but it's relatively subjective.
Yes. We talk about finding these anomalies and how they differ from the norm. Do you put any thought into the post anomaly detection process where what is this anomaly? What caused it? Can you classify it? Was it a server crash? Was it a mobile carrier issue? Does anybody look at it in order to maybe as a feedback loop back into the system to learn from that, to know what it is in the future if it happens again?
We do take that into account because we figured, we saw that it's absolutely required to try to do some of these things. Some of it automated, some of it maybe manual, but still you have to take them into account. We do take inputs from users that try to label what the problem was. And actually part of the way our system our product is expanding is to start talking about automating recovery actions from anomalies for cases that are clear. Not the esoteric anomalies, but I said that all anomalies are different. They are, but you can still find commonalities between anomalies, at least in how you solve them and what you do to resolve them. If you had a server crash, you reset that server, spin up a new one. If you have a problem with a carrier, you send through a different API. There are all sorts of remediation actions that people do when they see these type of anomalies, and some of them have a lot of commonality, and that's what the next phase of the product is, to learn those commonalities so we can at least recommend the remediation action and eventually maybe even take the remediation actions, have a system that takes the remediation action automatically for the clear-cut stuff. Think about a system that monitors, and we don't do water monitoring, but the analogy is to a system that does water monitoring in a large environment, a city, or for a lot of farms. You could take an action if you detect a leak of shutting down the valve automatically, and then have some technician or somebody come and take a deeper inspection. A lot of things you can do automatically that you don't have to know that the leak was because somebody left the water open in a bathroom or something else. You can still take the action and then have somebody take a deeper inspection to understand the actual root cause of it and fix it completely.
So let's talk a little bit more about baseline, because I find that fascinating about deciding what is normal, what is actually the normal behavior. And so how do you choose that? I mean, for different industries, does that change? Is there a granularity that works? Do you have any examples of where you really have to consciously decide what normal is?
Yeah, so at least in our product, we try to create that whole process to be fully automatic. What we designed into our algorithms are generic pattern learning mechanisms based on a lot of examples that we've seen that will search for those type of patterns. If you're looking at data that is fueled by actions of people, for example, how many people are playing a game on their phone at any point in time during the day. This is driven by human behavior, so it tends to have a lot of patterns that are seasonal, in the sense that throughout the day the pattern changes. There is a daily pattern, there is a weekly pattern, so things look typically different on the weekend than on the weekdays, and depending on geography. If they're from Israel, then the weekend is Friday, Saturday. If they're in a lot of the rest of the world, it's Saturday, Sunday. Holidays, all sorts of things driven by human behavior, will create kind of generic patterns that you can search for. And there could be patterns that are driven by machines doing actions every 30 minutes. So you bake into the algorithms looking for all these types of patterns that could exist and let it find it automatically. If it's number of people taking Uber, then you'd have probably a weekly pattern, you'll have a daily pattern, maybe you'll have a monthly pattern, you'll have spikes on certain holidays. I don't know if you know, but for example, St. Patrick's Day is a big spike in San Francisco and New York of taking ride sharing.
I can imagine.
Not in other cities, but in San Francisco, New York. So all of that you learn. You let the algorithms learn. You don't manually do any of this work. That's the beauty of machine learning.
Okay, but what about black swan events? Things that happen, once in a generation that nobody anticipates, is just completely upend the world order. Say, I don't know, just off the top of my head, let's say a global pandemic that shuts down the entire world. How does that affect your baseline and what's normal?
Very significantly, and we saw it quite. We saw it happening and unfold, within days, I guess, in March.
Oh wow! Okay.
Yeah, how the patterns changed for some companies. I mean, we had one customer who their pattern changed to the worse in they lost 95% of their revenue in a week.
Wow.
We've had other companies who spiked, and the patterns changed upwards, depending on the industry and what they were selling, and I won't go into details there, but you can imagine that anything related to travel tanked.
Certainly.
Anything related to digital services increased. It's not just the increase or decrease, the patterns themselves we saw change really dramatically. For example, telco providers, their patterns changed in terms of bandwidth and network quite significantly from being very, office-centric and home in the evening to being home all the time. And all of a sudden you've seen in these carrier networks, their entire network traffic patterns shifted very dramatically. Longer days, home more spread to residential areas, all of a sudden office areas and no traffic. And a lot of their assumptions of how the network operates were based on the normal patterns of pre-COVID, and that's why some of them experienced serious issues. Now, how do we deal with it? We allow the algorithms to be adaptive. So we let them constantly change and let them forget the history.
So they're constantly learning.
They're constantly never stopping.
And so how long would you estimate did it take the algorithms to adapt to this new normal?
It kind of, it's hard to say a number. For the significant cases, something like a week to 2 weeks to adapt to the new normal. In a lot of the cases, sometimes 3 weeks. But that's okay, because the beginning part, it's all an anomaly. It is an anomaly.
The whole world was an anomaly.
It is an anomaly. Yes. You can't say it's not an anomaly and immediately assume that this is a new norm. You have to also wait for a little bit. So any anomaly that changes the pattern completely and will sustain it will first look like an anomaly. And at some point you have to make a decision, okay, this is going to be my new norm.
Right.
And then you start learning it. So our system, has all the algorithms have this built-in mechanism that we designed from the start, because we've seen it happening on a much smaller scale all the time. Some businesses all of a sudden spike and have a significant boom in their traffic or their users, and it's normal. It's okay. You have to adjust to it. So you let it go as an anomaly for a little bit. And at some point, you let the algorithm start learning this as the new norm and start forgetting.
I would imagine that the changes in the baseline are starting back again. Is there an element or an era of instability while that's happening, or do you think now it would change in a more sort of even keel?
Some of it is actually cemented. It's changed and is now the new norm, and it hasn't changed back, and it's okay. I think
and
a lot of
I guess that's true. Like working from home is going to be a lot more.
Yeah,
so the bandwidth of the carriers, that's going to stay.
It's even though it got evened out a little bit more, but it changed slowly enough that the system adapted to it fast enough. So what we're seeing now is not rapid changes, but rather slower changes, and then because the system knows how to adapt itself, it's adjusting easily to those slower changes. So it's designed to adjust well to slow changes, and then detect when there is a fast change, which is the anomaly. An anomaly is, first you don't know whether it's a change, you just know it's an anomaly, and then after a while, if it lasts for a long enough time, you realize, oh, it's the new norm. What we did notice, which was interesting in this COVID behavior, is that the hardest thing to adjust to is things change exponentially. If you looked at actual COVID numbers, and this didn't happen to businesses, but if you look at the COVID numbers, like how many new cases, we all know about, the whole world knows about exponential increase, and now in a lot of places, and hopefully the rest of the world, exponential decay. Exponential increase and decay are exponential, so it's constantly going faster. It looks slow in the beginning, but then it goes faster and faster and faster and faster. So that creates a big challenge on a lot of machine learning algorithms to try to catch up, because it can't catch up. It's always increasing and increasing at a faster and faster rate. So that's the type of pattern that we've noticed our algorithms are not good at detecting, at catching up with, and they keep thinking that the increase is an anomaly. Now there is a philosophical question. You could model exponential increase and have a good model that will capture exponential increase, but is that good to call that normal? Because anything that's increasing or decreasing exponentially, you could argue, is something you want to closely pay attention to.
That's fair, especially in business. It does not imply any kind of stability.
Yeah, that's
in your business model.
Super unstable.
Yes.
That's super.
Yes.
I mean, any business wants their revenues to exponentially increase, but you have to pay attention to that, because that's weird. And exponential decrease is even worse.
Well, yeah, exactly. That's when things are spiraling out of control, and the algorithms are like, you know what, screw this.
Yes.
Not dealing with it.
Exactly.
We talked a lot about these different algorithms and mechanisms that I'm sure your band of data scientists at Anodot are very well versed in looking at. In general, what are the things that you look for in a data scientist, what you think are important for somebody who is either starting in data science or is looking for a job?
I would say, I actually almost never look for people that have necessarily specific knowledge in anomaly detection. It's a plus, but I don't.
It's a skill that you can learn.
It's a skill that you can learn. It's a field that you can learn. Algorithms, learning about algorithms, that's all of it you can learn. The things that I think the thing that I focus on when I look for people, and this is my advice for anybody who wants to go into data science or feels that they want to be a data scientist, is to think about how you approach problems. The interesting thing about data science, machine learning and data science in general, is that data fuels data science, but you're trying to take data and transform it into insights, into information. And that process is actually a process that requires a researcher's mind, in my view. Somebody who likes to take problems that there is no one solution for, because it's fueled by data, and the data can tell you a lot of things, and iterate over that problem until they get to a solution that is good for the problem they try to solve. When I look for a data scientist, when I interview somebody, I ask them general questions to see how they deal with uncertainty, where they understand that the first cut of analyzing the data for that process will probably not produce the right results, and the second time probably will not produce the right result, and maybe the 100th time will not produce the right result. But they'll have they won't despair. They actually would like that process of going over and over and trying one more thing and then one more thing and another thing and another thing, and transforming the data in this way and that way. And that's the researcher heart.
When I look at resumes and you have, you're listing off all the different types of models that you've either been exposed to or ran in a project once, I don't care that much, because you can learn those. If you need to learn one of those things, it's a skill that you go, you read, you learn. But do you have curiosity about data? Do you enjoy asking questions and trying to find answers? Are you creative with the way that you think about it?
And that's the researcher mind.
Yes.
Constantly asking those questions.
So Ira, this has been really, really fun and very, very illuminating. And I'm very happy that we're able to sit down and have this conversation. But now looking forward in 2021, what is, now that we're coming out of COVID and now we have to start traveling again maybe soon and meetings and running around, what are you excited about for the near future?
So first, I am excited about going back to travel. I just booked my first vacation in a year and a half.
Oh wow, where are you going?
Flying out to the Seychelles Islands.
Nice.
Yeah, so that's very exciting. Not having, not the flight itself, but actually going out a little bit.
Now, when you go to a place like the Seychelles, do you disconnect completely, or are you still going to be checking your email?
I plan to disconnect completely.
Wonderful. That's what I wanted to hear.
I think that after a year and a half, it's time to disconnect.
Absolutely.
But the things that I know that excite me is a lot of the things that I've started, getting interested in that are not necessarily just my work. Like I mentioned, I read a lot and listen a lot about things in neuroscience, and I think there's a huge potential of data science meeting neuroscience. There's so many new discoveries that help us explain, ourselves, and that's really exciting. And if I was going to do another PhD, it would be in neuroscience. That's for sure.
Well, maybe the next pandemic, that'll be time to sit down and do that.
Exactly. Well, maybe I'll take the time and do it.
Or that.
And it's
from the Seychelles.
From the Seychelles. And so what I will take is, making sure that I have the time to not give in to the old ways of not setting time for other things in your life and just being kind of, I don't like the word slave. I don't feel I was a slave to my job or a slave to what I was doing. I really enjoyed it. I still enjoy it immensely. But I think I have a much deeper understanding of the need to balance things out.
Yes.
And constantly seek out to learn new things that are outside of your main domain, because that really first, it's the fuel to help you sustain your main thing. Mm-hmm. And it helps you with your main thing as well.
Yes, it informs your perspective on your main thing as well. So where can people reach you if they have any more questions about Anodot or about anomaly detection in general?
So they can look me up on our website, which is anodot.com. That's ANODOT.com. They can also reach out to me on LinkedIn.
All right. Thank you so much, Ira. This has been fun.
Yes, this was really fun and really exciting to do this face-to-face.
Oh my God, that's the best part of it. Yeah. I completely agree with that.
Well, thanks for joining us today and listening to this episode. Please remember to subscribe, rate, and review our podcast. And if you have any questions you'd like addressed, send them to who'syourdatanow@gmail.com. That's who'syourdatanow, all one word, @gmail.com. Thanks, and see you next time on Who's Your Data?